Good afternoon, class. We are looking at exam 4 review, chapter 4, application of differentiation, chapter 5, integrals, 6.1, areas between curves. And here's part 4, covering 5.4, indefinite integrals and the net change theorem, and 5.5, the substitution. Indefinite integrals and the net change theorem. Net change theorem. The integral of a rate of change is the net change, the integral of a to b, f of x dx, or the integral of a to b capital F prime of x dx is capital F of b minus f of a. This is the one of the FTCs. FTC meaning fundamental theorem of calculus. This principle can be applied to all of the rates of change in the natural and social sciences. We're going to look at some examples, but let us start it with the integration. An example of that, as you can see that we have square root of x here, and we have to change it to x to the power 1/2 first. And we make up two fractions. And this one, remember, the exponent for x is 1 here. Therefore, this is x to the power 1/2. This is x to the power of negative 1/2. We follow the power rule. So 1 over 1/2 plus 1, x to the power of 1/2 plus 1. For this one, 1 over negative 1/2 plus 1, x to the power of negative 1/2 plus 1, and a constant. And believe it or not, this is the only calculus step. Now 1/2 and 1, they add up to 3/2. Negative 1/2 and 1, they add up to 1/2. This is the reciprocal. When you divide by 3/2, is the reciprocal of 3/2 becomes 2/3. This one becomes 2. So 2/3 x to the power of 3/2 plus 2x to the power of 1/2 plus a constant is the final answer. A bacteria colony increases at a rate of R of t equals 2.2 e to the power of 0.4 t. Remember, the moment we hear rate in calculus means the derivative. 2.2 e to the power of 0.4 t bacteria per hour. If the initial population is 800, that really makes it an initial value problem. Find the population after 12 hours. So we can do this two different ways. First of all, this concept of the net change theorem applies. So if this is the rate, let's go with capital R of t representing the actual population. Therefore, capital R of t represents the population, and its derivative, capital R prime of t equals lowercase r of t represents the growth rate, and this R of 0 is equal to 800. Again, that is the initial value problem in essence. So according to the accumulated change theorem, the net change theorem, the amount of increase that takes place over the course of 12 hours is the integral of 0 to 12 R of t dt, lowercase r, the rate. We replace this, and we're going to integrate that. Now, in the case of a exponential, when you differentiate or integrate, you get the same thing. In the case of a differentiation, you multiply by that. In the case of a integration, you divide by k. So 2.2 divided by 0.4. Which means 22 over 4, 11 halves of 5.5. So you plug in the upper limit 12 minus, plug in the lower limit 0, keep the 5.5 out. This is anyways e to the power of 0 or 1. But nevertheless, you have to use a calculator. This is 4.8. And because it refers to the number of bacteria, and this is 8, we go with 663 because we go with the nearest whole number. Initially, there were 800, so they add up, and R of 12 becomes 800 plus 663, or 1,463. So that's one way to do that. The second method is to find R of t. That means in this case, if we integrate without the limits, we get this one and a constant. So we integrate that and we've done the work. 5.5 e to the power of 0.4t plus a constant. And we know that R of 0 is 800. So 5.5 e to the power of 0 plus c is 800. E to the power of 0 is 1. 5.5 plus what number is 800 makes it 794.5. So that becomes R of t. Bear in mind, this is a general solution. This is a particular solution. And what do we want? We want population after 12. Now, the advantage of that, and that gives you the same number. The advantage of that is if we want the population after 10 hours, 15 hours, 18 hours, in one shot, we put it here instead of going through the process again. All right, let's evaluate the integral sine 2x over sine x dx. We recognize sine 2x as 2 sine x cosine x. These two cancel each other, 2 cosine x dx, and we know the integral of cosine is positive sine, so 2 sine x plus a constant is the final answer, everybody. And there's really not much to do here. This is 1 over x in essence, which is a natural law. And you plug in, this is ln of 6 minus ln of 3, or ln of 6/3, or ln of 2. Many fish grow in a way that is described by the von Bertalanffy growth equation. For a fish that starts life with a length of 1 centimeter and has a maximum length of 30 centimeters, this equation predicts that the growth rate is 29 e to the power minus x centimeters per year, where x is the age of the fish. How long will the fish be after 4 years? Rounded to 1 decimal. All right. Again, first, let's understand that rate refers to the derivative function. So if we let L of x, because we want to see how long it is, represent the length of fish at any age x, then the growth rate that makes it the derivative of this function with respect to x, L prime of x, so dl dx is this. And what is this one? Initial value problem. L of 0 equals 1 centimeter. So that is understanding the problem. And again, we are using the accumulated change the net change theorem. So the amount of increase over the course of the 4 years is the integral of this from 0 to 4. Of course, we need a dx there. So it's the integral of 0 to 4, 29 e to the power minus x dx. That's the amount of increase. The integral of exponential is itself. We divide by -1, we get -29 e to the power minus x. We evaluate it from 0 to 4. Again, putting in -29 out, evaluate this one. This is obviously 1, but nevertheless, you need a calculator. I'm going to put it with a bunch of decimals first. And then L of 0 is 1. I'm going to add. And now, when I'm done, I say, okay, I need 1 decimal. So I need 4. Next to it is 6. It goes up to 5. You always do the rounding accordingly. And again, just like the question we did previously, we can do a second method by finding L of x. Simply integrate this without the limits. And we already have the answer. So this one plus a constant, well, L of 0 is 1. So this is a general solution. This will help us find one solution, a particular solution, plug in 0. When we plug in 0 minus 29 e to the power minus 0, this is 1. So we get minus 29 plus what number is 1? Of course, the answer is 30, which makes this function L of x is -29 e to the power minus x plus 30. So how long is the fish? After 4 years, plug in 4. 5, plug in 5. 10 years, plug in 10. That's the advantage of this. So if you have several parts, this makes it easier. And I put it with the same number of decimals as this one just to make a point. All right, so the accumulated change, the net change theorem application. A particle moves along a line so that its velocity at time t is v of t equals t squared minus t minus 6. Measured in meters per second. Find the displacement of the particle during the time period t between 1 and 4 inclusive. So we want the displacement, and there's also a part about the distance. So here's what I want everybody to know. As you go from one point to another, distance is the integral of the velocity, so is the displacement. Distance is the absolute value of the velocity being integrated dt. So it would be the sum of all of those. But displacement is just the integration, and some of them are positive, some of them are negative. Which part is positive? The one below. So it would be A1 minus A2 plus A3, whereas for in this one, since you're using an absolute value, it's always positive. So if we want to explain it in a different manner, if you want to go from point A, everybody, let's say to point B, this is your displacement. Distance, I'm sorry. This is your distance. You cover from A to B. But what if it's not a straight? There is no straight, road between the two, and you may have to go like this, and then like that, and like this, and like that. Then you have to cover this much, plus this much, plus this much, plus. You just went from A to B. That was your displacement, but the distance you covered is a lot more, and that's the concept. Okay, so let's erase that. So the integral of v of t dt from 1 to 4, which is really s of 4 minus s of 1. So that's the fundamental theorem of calculus. And as I mentioned, that represents the displacement. So we have this here, t2, t squared minus t minus 6. This becomes 1/3 t cubed minus 1/2 t squared minus 6 t from 1 to 4. And I'm going to leave it for you to evaluate it. Just plug in 4, plug in 1, and the difference, and it becomes negative 1/2. And displacement can be negative. If you look at this one, if by any chance this is larger than the sum of those two, could be negative. So what does it mean? The particle moved 4.5 meters towards the left, in essence, towards the negative side. Find the distance traveled during this time. Now we want the absolute value. We want to take the integral of v of t dt, but this time it's absolute value from a to b, and we go from 1 to 4. And now, how do you do that? You have to go with the number line to figure out and the sign graph to figure out which part is positive, which part is negative. So first and foremost, this function, we are going to factor it into t plus 2, t minus 3. 1, 2 numbers, the product is negative 6, the sum is negative 1. So that's the factored form, everybody. Now we want to use a sign graph at, so if you set this equal to 0, t, this gives you negative 2, this gives you positive. This gives you positive 3. So you go with the number line, and normally we go negative to positive infinity. In this case, we are really going from 1 to 4. So in essence, somewhere here to here. However, we need the sign. So I'm going to do the sign for all of them. To do the sign, we pick a test point, everybody. I'm going to call it TP, short for test points. So obviously, between negative 2 and 3, the easiest one is 0, right? To the left of negative 2, let's say negative 3, and to the right of 3, let's say 4. However, you really need only this to figure out what happens. Here's the reason. The velocities of degree 2 has 2 answers, so that means each one has exponent 1 or odd. So if you find this one, whatever the answer is here, the other ones must alternate. So if I put 0 into this, I get minus 6. So it becomes negative, or you can use this. This is negative, this must be positive, this must be positive. They will alternate, which means, let me erase my work. Which means from here to here is negative, from here to here is to positive, and so 1 to 4. Remember, 1 is somewhere here, right? Doesn't have to be the scale. So from 1 to 3, it's negative. From 3 to infinity is positive, and remember, we're going to go to 4, right? So 4 is somewhere here. So from 1 to 3, because it's negative, we're going to use the opposite of that. That's how you do the absolute value. Remember that. And from 3 to 4, that is positive, we use the same function. So the integral of 1 to 3 minus v of t dt, y minus, because it's negative and we are interested in an absolute value, we use the negative of that. But from 3 to 4, the function itself. So plug in, this becomes minus t squared plus t plus 6, and this one is itself. And now this one is negative 1/3 t cubed plus 1/2 squared plus 60. And from 1 to 3, this one is 1/3 t cubed, just like this one. Okay, that we've done. And from 3 to 4. Again, this takes a little bit of a time to calculate. The precise answer is 61/6, or about 10.17 meters. Distance uses the absolute value, and it's always positive. Displacement does not use the absolute value. Could be positive, negative, you name it. All right, difference between a value of a definite integral and total area. Again, it's a similar concept here. It says find the area between the x-axis and the curve y equals cosine x from 0 to 3 power 2. So if you want to find the area, you got to be very careful, class, because if you just find the integral of 0 to 3 power 2 cosine x dx, that gives you the difference, because as you can see, this is positive above the x-axis and this is negative. The positive part, you use the same function, cosine, so it's cosine x dx. But the negative part, you use the opposite, minus cosine x again. So to find this area and this area and add them up, because if you don't have the absolute value, it just gives you the difference of areas. So again, this is a graph of a cosine function, reminding you. It's a complete cycle, right, everybody? And this is power 2. This is 3 power 2. This is pi 0, 1, 2 pi. Okay, so we know it's power 2, so that one we need a cosine. But from here to 3 power 2, it's negative. We need minus cosine. I'm going to erase my work to finish the job. Cosine gives you sine. Remember, the derivative is negative, but the integral is positive. So this is sine x from 0 to power 2, plus minus becomes minus sine x from power 2 to 3 power 2. This is sine of power 2 minus sine of 0, minus the parenthesis sine of 3 power 2 minus sine of power 2. So sine of power 2, we know 1. Sine of 0, we know it's 0. Sine of 3 power 2 is negative 1. And minus sine of power 2 is positive 1. So notice what happens. 1 minus 0 minus. This is negative 1. This is minus positive 1. So this becomes negative 2. This makes it positive. They add up to 3. However, if we wanted to find the value of the definite integral of 0 to 3 power 2 cosine x dx, then we would evaluate this one from 0 to 3 power 2. And that becomes sine of 3 power 2 minus sine of 0. You know sine of 3 power 2 is negative 1. This has no bearing. So the answer becomes negative 1. And it's obvious there. The reason is because this is 2, this is 1. They add up to 3. But if you are going to go here, 2 minus 1 becomes, minus 2 plus 1 becomes negative 1. That's so just in case. The substitution rule, integration by substitution, is the reverse process of the chain rule in differentiation. How do we differentiate this using the chain rule? The dx of capital F of g of x is capital F prime of g of x, g prime of x. Normally, capital F prime is lowercase f, so f of g of x, g prime of x. So we let u be g of x, then du dx is g prime, and du is g prime of x dx. So the integral of f of u du is capital F of u plus c, or capital F of g of x plus c. Over any interval for which u equals g of x is continuously differentiable and f is continuous on the range of this function, the following relationship holds. The integral of f of g of x, g prime of x dx. Notice we let g of x be represented by u, and then g prime of x times dx is du. So this is the integral of f of u du. That's why it's known as the substitution rule, or the u substitution. So capital F of u plus c, or capital F of g of x plus c. And we're going to practice with that. Again, the idea is that if you integrate this one times dx, you're supposed to get to this one, obviously, because you started with this differentiated. So in short, again, substitution is the reverse process of the chain. All right, so here's the tip in general. Look for a function u equals g of x anywhere in the integrand, and its derivative du, or g prime multiplied by dx. So we're going to look at various functions. What I want you to know is that when we have polynomial functions, in this case, x squared plus 5 is a polynomial function, so is 2x. The more complicated function is a choice of u. So x squared plus 5 is a choice of u because it's more complicated than 2x. Notice if I differentiate this, du dx becomes 2x. Which means du is 2x dx. So I'm going to rewrite this in this fashion by moving 2x next to dx, so it becomes clear to everybody. This is u, this is du. So we have the integral of u cubed with the du. And that uses the power rule. Becomes 1/4 u to the power of 4 and a constant. And u, reverse substitution, u is replaced with x squared plus 5. And that's the final answer, 1/4 x squared plus 5 to the power of 4 plus c. Now, a couple of things I want to mention. Number one, as always, you can differentiate this. You get the same thing without the dx, number one. Number two, many times students write du without the dx, which is wrong. Dx has to be written. The integral of 5 plus 2 cosine theta d theta. I want you to notice theta is the independent variable, so 5 becomes 5 theta. Cosine, the derivative is negative, but the integral is positive, so it's positive plus 2 sine theta and a constant, and you're done. When you are integrating and exponential is involved, the exponent normally is the choice of u if you have to go with the substitution. The derivative is 5x to the power of 4, which makes du 5x to the power of 4 dx. I can't emphasize this enough. We have to write the dx, everybody. Now we're going to move things around as we do that. In other words, we put the x to the power of 4 next to dx. We notice, okay, everything is in order except number 5 is missing. Now, in many texts, including yours, they solve for dx. And that's fine. But let me show you quickly a faster and easier way. 5 is a number that is missing. So if I plug in 5 here, I can undo it with its reciprocal 1/5. You can only do that with numbers. So one more time. I need number 5. I put it in. How do I undo it? 1/5. By the way, 1/5 in or out makes no difference. The 5 in or out makes no difference. You know that inside the integral sign or not. And now you're dealing with e to the power of u du, which the integral is itself. So 1/5 e to the power of u and a constant. And u can be replaced with x to the power of 5 minus 2, and we are done. I want you to see this question side by side, and there's a reason for it. Rational functions, or even a fractional format, the very first step is to simplify if we can. This one, this number is 2 is a prime number, so the product is 1 and 2. 3 is the product of 1 and 3, one of them negative. So you factor the denominator. But remember, even if you can factor it, but it doesn't simplify, it doesn't help. Therefore, you don't need it for this question. But I did that on purpose, so you see, can be factored, doesn't do us any good. So u is what? Anytime you have a fraction, the denominator, and you have to use the substitution, the denominator is a choice of u. So the denominator is a choice of u. If I want to differentiate this, I get 4x plus 1, the numerator. So du is 4x plus 1 times dx. I'm going to rewrite this. And by the way, dx always belongs to the numerator. If it's in the denominator, there's a typo. That makes no sense whatsoever. So you're looking at du over u, and this is going to use natural log as the answer, just like this one. So ln of absolute value of u plus a constant, replace the u, and you're done. So what's the difference between these two? Well, the numerator is 4 times x minus 1. That's the difference, which means I can simplify. And you must always work with the simplified version of a fraction. So that's the difference between the two. So I want you to see them side by side. There is no more simplification. Denominator is a choice of u, and the derivative is 2. Therefore, du is 2 dx. As always, dx belongs to the numerator. So the numerator is 4 dx, 2 times that. So I'm going to rewrite it in the following manner. So I'm going to write the integral. I'm going to write 2 dx times 2. Please understand, I have the same thing here, 4 dx, 4 dx. But the reason I'm going to write it in this format so it becomes clear, This entire thing is du, this entire thing is u, and this, again, just like that, gives you a natural log. Of course, the 2 remains. Reverse substitution, bring back the u, and the final answer is 2 ln of absolute value of 2x plus 3 plus c. By the way, I have to keep the absolute value because this expression can be positive or negative, the same thing here. Now, I want to look at reciprocal of one of those, and I want to look at the reciprocal of this one. Reciprocal of this one becomes, so x minus 1 drops, becomes the reciprocal of this one. Why am I looking at that? Again, on the same page, because I want you to compare and contrast. I no longer need substitution. Rather, this is half of x, this is 3/4. X itself becomes half of x squared, with this becomes 1/4 x squared, this is 3/4 x, and a constant, and you're done. So this one, I have to go with the substitution, simplification and substitution. This one, I go with the simplification first, but there is no need for substitution, and that's the key here. You use the substitution if you have no choice. So pretty straightforward. Again, I want you to see both of them side by side. One, this one is a rational function. It's not, but both of them are fractional format. The very first step, simplify if you can. Can't simplify, the denominator is a choice of you. Notice if I differentiate this, I get the numerator e to the power of t. Therefore, du is e to the power of t dt. I'm going to put the dt up so it becomes clear again. We are looking at the integral of du over u. We've seen this by now quite a few times. Following this, we get a natural log and a constant. Reverse substitution, natural log of 5 plus e to the power of t plus a constant. Uh, I hope everybody recognizes 5 plus e to the power of t as a positive value. You could drop the absolute value and use parentheses if you. Same thing here. You are going to simplify first, but it can't be simplified. The denominator can't be simplified. Why is that? Reminding you of the quadratic formula. Ax squared plus bx plus c equal to 0. X is minus b plus minus a squared of b squared minus 4ac over 2a. And b squared minus 4ac is the discriminant, everybody. Positive means two distinct real solutions. 0 means one, and less than 0 means no real solutions, two complex solutions. Okay, what else? If b squared minus 4ac is a perfect square, that means this can be factored. And the idea is that this can't be factored because for this one, a is 1, b is 2, c is negative 1, and b squared minus 4ac, if you work it out, you get 8, which is not a perfect square, cannot be factored. I'm reminding you of something from algebra. So it can't be factored, so that's a choice of you. If I differentiate, I get 2x plus 2. So du dx is 2x plus 2 or 2 times x plus 1. So what is du? 2 times x plus 1 dx. I'm going to put the dx up. And again, I want you to compare. Notice, as I mentioned in many texts, they solve for dx. This is much easier. Number 2 is missing. Just put a 2 here. So if you put a 2 here, what do you put outside? It's reciprocal 1/2. Why? You can't just multiply by any number, but you can multiply by 1. The product of these two is 1. And now you're again looking at this part, the integral of du over u, half of natural log of absolute value of u plus a constant, reverse substitution, and you must keep the absolute value because the expression x squared plus 2x minus 1 can be positive or negative. So the final answer is 1/2 ln of absolute value of x squared plus 2x minus 1. Now, I want to look at the uh, reciprocal of this one or this one. Either one, you don't have to do the substitution. If you look at the reciprocal of this one, you have to use long division or synthetic division. If you look at the reciprocal of this one, this is one fraction, gives you 5e to the power of negative t, and this one gives you the second one, plus 1. So this is one fraction. This is second one. And now this one becomes minus 5e to the power minus t. This one becomes plus t, plus a constant, and you're done. The point being, because it's a fractional format doesn't mean we need to use substitution. Sometimes we do, sometimes we don't have to. Okay, let's integrate the square root of 3x plus 7 dx. So u is 3x plus 7, and if you differentiate it, you get 3, therefore du becomes 3 dx. Now, the reason I've chosen this question, because this is simple enough, I want to do it both ways. I want to do it my way, and I want to do it the way they do it, solving for dx. So if I want to solve for dx, du over 3. And I'm showing you it works out the same way. And in this case, it's really not much of a difference, but most of the time, the method I do it, it's faster and easier. So we're going to rewrite this, and we are going to replace the dx with du over 3, which means I'm going to take the 1/3 out and write it as u to the power 1/2 du. So this is the method that most texts do. They solve for dx. What about me? Here's what I do. I rewrite this, I put this in a parentheses, and I come back here and I say, okay, what is missing here? Number 3. If I put number 3, what do I need? Outside, 1/3. I throw in 3 and 1/3, and it's identical to this. I hope, of course, we have to change it to you. I think it's easier and faster. It's your choice. We are going to finish the job on this piece. So 1/3 remains. Now let's work on this. The power rule, of course, 1 over 1/2 plus 1 u to the power of 1/2 plus 1, and a constant. This is 3/2, everybody. The reciprocal is 2/3. Multiply, and you get 2 over 9. Replace the u, 3x plus 7, and you're done. The final answer is 2 over 9, parentheses 3x plus 7 to the power of 3/2. plus a constant. If f of x is 4, e to the power of negative 0.2x minus sine x, we want to differentiate and want to integrate. The reason I want to do that because I've seen students making a mistake when it comes to exponentials and trigonometric functions. So let's do both of them at the same time. It would be truly helpful. So we want to differentiate this. Remember, when you are differentiating exponential, the answer is itself. So the answer is itself. But you multiply by k if you want to take the derivative of e to the power of kx is itself times k. So the same thing times k in this case is negative 0.2 minus sine, the derivative is cosine. All right, so this would be negative 0.8 e to the power minus 0.2x minus cosine x, and we are done. Let's integrate. To integrate, we're going to multiply this by dx. Okay, class, we need a dx because x is the independent variable. We put the dx. That's extremely important to pay attention to. Now, we multiplied by that. Now we're going to divide by it because we are integrating. And the derivative of sine is positive, but the integral is negative. So this becomes minus cosine x, with this one gives us plus cosine x and a constant. So I just wanted you to see, compare, and contrast. Therefore, capital F of x is, of course, 4 divided by minus 0.2. It's just 40 divided by 0.2 and then negative sign. And maybe I write that. This one is the same as 40 divided by negative 2. So minus 20 e to the power minus 0.2x plus cosine x plus a constant. Finally, let's make it the initial value problem. What if we have capital F of 0, in other words, going back to part B, equals 20? That means this is a general solution. Now, one point will help us find one of those solutions. So let's plug in 0. So capital F of 0, so you put 0 here. It's supposed to get 20. E to the power of 0 is 1. So this becomes negative 20. Let me just. This is 1. This is 1. So minus 20 plus 1 is minus 19. Goes to the other side, becomes positive 19. C becomes 39. When you plug in, capital F of x becomes the same thing that we had here, minus 20 e to the power minus 0.2x plus cosine x, and a constant C is 39, and a particular solution is found using an initial value condition.